Question 9 is saying the diagram shows a displacement time graph for a transverse wave. We've got displacement on the y, and we've got the time on the x-axis. Now the question is asking us to say, how long does it take to make 2.5 waves? 2.5 waves. So first what we need to define is a wave. A full wave is the top part and the bottom part coming together to form one full cycle. So if we have one full cycle, it means we have one wave. So if we look at it, this top part and this bottom part coming together will give us one complete cycle, that is one wave. And this top part and this bottom part coming together will form two waves, and just the top part there will give us half a wave. So this is 2.5 waves. So how long does it take to make 2.5 waves? We will pick the time that we have at the end there, which is 2.5 seconds. So our answer there is D, 2.5 seconds. We can move on to question 10. Question 10 is saying, which statement about refraction is true when light passes from air to glass in it? Or rather, which statement about refraction is true when light passes from air to glass? It A, speeds up and wavelength decreases. B, slows down and wavelength decreases. C, speeds up and the frequency decreases. D, slows down and the frequency decreases. Okay, so what happens when refraction occurs? So what is refraction? There is reflection, and we've got reflection, and refraction. Reflection is simply the bouncing back of light. We've got a medium there. That is reflection. But when we talk of refraction, with the medium there, light is coming. Refraction is simply the bending of light. Refraction is the bending of light. Reflection is the bouncing. So reflection and refraction. So reflection, bouncing back. Refraction is the bending. So what happens for when light bends? Is it A, it speeds up and the wavelength decreases? B, it slows down and wavelength decreases? C, it speeds up and the frequency decreases? And D, slows down and the frequency decreases. So our answer in this case would be, answer is B, it slows down and the wavelength decreases. So when you're dealing with refraction, what happens is the speed of the light waves decreases and their wavelength decreases. So when we talk of wavelength, we're simply talking about the length of the distance between two successive crests. So in this case, this is a crest, this is a crest. So a wavelength is simply the distance between this one and that one, which is the same as the distance from there to there. That is the wavelength. So the wavelength decreases, and also the speed of light of the light also reduces. Move on to question 11. So question 10, the answer is B. Question 11, in order to produce a sound wave, they should always be. So sound is simply vibrations. So you can't have sound without vibrations. So our answer to question 11 should be vibrations. We don't even have to go into details on that one. But you need to remember to say sound is a product of vibrations. Okay, move on to question 12. Question 12 says, the figure shows a negatively charged polythene rod moving closer to a metal sphere, which is on an insulator. There is a wire from the sphere to the ground. Which of the following is true? Okay, so there is our sphere. We have our sphere there. And the question is saying, which of the following is true? Side X of the sphere is charged negatively. Side X of the sphere receives protons from side Y. C, conventional current flows to the sphere. Side Y of the sphere receives protons from side X. Okay, so when you talk of charges, we've got negative there. we should always remember to say opposites attract. So if we've got negative, negative attracts positive, positive attracts negative. So if you put a negatively charged polythene rod there, it means that you're going to have positively charged charges on the side that is nearer to the negative. So in short, our answer should automatically be one that is telling us to say side X has got the positively charged protons, or positively charged protons that have followed that have been attracted to the polythene rod, which is negatively charged. So when we look at the answers, option B that we have, option B is the closest and is telling us what is really happening, because option B is telling us to say side X of the sphere receives protons from side Y. Protons are positively charged elements. So protons are attracted from side Y to side X because of the negatively charged polythene rod that we have on the left side. We can move on to question 13. Move on to question 13. It says, which of the following quantities is expressed in the same unit as potential difference? So when you're talking of electricity, you're talking of potential difference, talking of PD, it is the same as the potential difference is measured in volts. And this, let's look at the options that we have: positive charge, electromotive force, electric current, electric power. So electric power is given by watts, electric current is given in amps, positive charge is a positive charge, but electromotive force is the same has got the same units as the potential difference, which are the voltages, which are the volts. So our answer for question 13 is B, which is electromotive force. Question 14 says, which of the following circuits containing identical resistors will give the highest current? Which of the following circuits containing identical resistors will give the highest current? So for you to have current, you need to know to say the formula that you use for current to find current is current is equal to the voltage over the resistance. So for you to have the highest current means your resistance should be at its lowest. The value, your amount of resistance should be the lowest. If you have the highest amount of resistance, it means your current will be very, very small, because you're going to have a big number at the bottom as a denominator. What do I mean? When you've got, let's say our voltage is 4, and we've got two currents, we've got two resistors, one is 2 and one is 6. If you say 4 divided by 2 to give you 2, but if we say 4 divided by 6 to give us 2 over 3. So 2 over 3 is less than 2. So if you want to have the highest amount of current, you should have the lowest amount of resistance. And if you want to have the lowest amount of current, you should have the highest amount of resistance. So let's go back to the question. It says, which of the following containing identical resistors will give the highest current, will give the highest current? Okay, so if we have current, if we have resistors in parallel, and you have resistors in series. When you're dealing with resistors in series, to find the total resistance that you have, we simply... So the best way that we can tackle this question is by trying to draw each of the circuits that we have. So for A, we've got a circuit that has two resistors in parallel. So to find the total resistance of two resistors in parallel, what we say is 1 over the total resistance equals to 1 over resistance 1 plus 1 over resistance 2. Okay, so let's get into that. So to find the total resistance in A, we're going to say, let's assume that this is 2 ohms. So we're going to say 1 over 2 plus 1 over 2. Half plus half will give us 1. So 1 over total resistance equals 1 over 2 plus 1 over 2 is half, so we've got 1. And to find the total resistance, we'll cross multiply. We're going to have total resistance equals to 1. Okay, So this is our A. We come to B. For B, this is A. So for B, we're going to say this is 2, this is 2. So to find the total resistance, we're going to simply say 2 plus 2. And this will give us 4. So total resistance in B is 4 ohms. So we've got B there. This is our B. And we assume this is 2, this is 2, this is 2. We're going to have 2 plus 2, okay, so this is C. We're going to have 2 plus 2, this is 4. 4, 1 over total resistance equals to 1 over 2 plus 1 over 4. So this is 2, which will give us 4. This is 4, this is 2. We've got 1 over 2, 1 over 4. So 1 plus half plus quarter is going to give us 1 over RT. This is going to give us our common denominator in that case would be 4. We're going to have 2 plus 1. This is equal to 3 over 4. We're going to have our total resistance equals 3 over 4. So to find the total resistance, we cross multiply. We're going to have RT equals to 4 over 3. Okay, this is our C. We come to D. D has got 2, and then we've got 2, 2. And we know that 2, 2 gave us 1. So we've got 1 plus 3, 1 plus 2, which will give us 3. So D has got total resistance equal to 3. So therefore, the one with the lowest amount of resistance is A. So A has got the lowest amount of resistance, and just as we had said, current is measured or is evaluated by the expression voltage over resistance. So for us to have the highest amount of current, we need the lowest amount of resistance. So therefore, our answer for question 14 is A, which has the lowest amount of resistance. We can move on to question 15. The formula used to find electrical power is, so power is given by voltage multiplied by current. No need to go through all the other questions, all the other options that we have. Power is given by voltage multiplied by current. You should always remember that equation. So question 15, our answer is A. Question 16 says the diagram below shows a magnet moving into a solenoid. Which of the following is true? So there is our solenoid, there is our magnet. Which of the following is true? A, if R is the south pole, the induced current flows in the direction shown by arrow M. B, if R is the north pole, the induced current flows in the direction shown by arrow M. C, if B is the south pole, the induced current on phase T of the solenoid flows clockwise. And D, if B is the north pole, no current is induced in the solenoid. Okay, so let's analyze the diagram that we have together. We've got this is a solenoid, and we've got our magnet that is going in that direction. The magnet is composed of two poles, R and B. We are looking for which one is the north and which one is the south. So what we need to remember is, if the north is this side and you're making the magnet go in like that, it means that the induced current in the solenoid will be flowing in that direction. And this would be your north and this would be your south, such that at the end there you've got the south and yeah. So looking at this question, the correct answer should be C. If B is a south pole, such that this is a south pole, if B is a south pole, the induced current on phase T of the solenoid flows clockwise. So if we said R is the south pole, shown by RM, this would be wrong. If we said R is the north pole and the induced current flows in the direction shown by RM, meaning to be going in the counterclockwise direction, and that would make that answer wrong. So if we had gone with this one, it meant that the arrow should have been pointing in that direction. But since we've gone with this one, it means that the current is going in that direction, meaning coming from this side, going to that side. Okay, so we can move on to question 17.